Good morning, class. The session is being recorded. So again, if there's any privacy issue, okay, make sure everything is muted, audio, video, don't put anything in the chat, even you can change your name to your initials. We are looking at exam one review limits. It's gonna cover sections 1.6 to 3.1. Okay, so here we go. All right. Here's an example I picked up from the exam review. Okay, so basically this has a few parts. If you separate them into three pieces, the fact that it's alternating, positive, negative, or negative, positive, it doesn't matter. It is alternating. And the first one is positive, then negative, so on and so forth. That's one part. The other part is that you look at the top and you look at the bottom separately. That because it is a little bit more complicated than usual. That's why. So three parts. One of them is a negative sign. And when it comes to a negative sign class, it is always one of these two. By the way, negative 1 to the power of n plus 1 gives you the same result. So the question is which one? Are we going to use this one or are we going to use this one? All you have to do, replace the n with 1 and observe what happens for the first one when it comes to the sign. If you change this to 1, gives you negative 1. And if you change this one to 1, this gives you positive 1. What is the sign of the first one? Positive 1. So therefore, that's the one. Done. The next one, look at the top, 6, 10, 14, 18, 22. Now you don't have to worry about the sign. What are we doing? We are adding 4. So that's an arithmetic sequence. That's an arithmetic sequence, class. Okay, and you use a sub n equals a sub 1 plus n minus 1 times d. Okay, a sub 1 is 6, d is 4, and you go through the process. A sub 1 plus n minus 1 times d. A sub 1 is 6 plus n minus 1, d is 4. And I hope you realize this becomes plus 4n minus 4, and therefore we get 4n plus 2. The last part, the denominator, just write them down and notice this is a geometric sequence because the first one, 3 times 3 is 9 times 3 is 27. So geometric sequence a sub n is a sub 1 times r to the power of n minus 1, right? And what is the first term? 3. And when you divide, it happened to give you 3 also. Even the r is 3. Now put them all together. This one, the numerator, the denominator, and you are done. That's how fast it goes as long as you realize you're dealing with 3 different parts. Okay. So cut them into 3 pieces. There you have it, and you're done. Okay. All right. In this case, we've done this before, so let's quickly go over that for everybody. Okay. N, replace it with 1, 2 minus 4, negative 2. Replace it with 2, 2 squared, 4 minus 4 is 0, and so on and so forth. So as long as you can show 2, you can show the rest of them. The third one, 2 cubed, 8 minus 4 is 4, and then you can write it down. Again, all you have to do, show 2 of them with details, everybody, with details. I hope you remember this question. Now, what happens here? First, let's see the meaning of this. The first term is given. The second term is given. Now we want more of them. How many more? We want 4 more because we want a total of 6. A sub n plus 2 is a sub n plus 1 plus 2 a sub n. That means if I want a term, a sub n plus 2, I need the previous one. This is before this. and plus 2 times before this. That's really the case. So n plus 2. So if the next one is a sub 3, and you can even change this number to 3. If you change this to 3, then n becomes 1. Can even do that. So this is a sub 3. Now if n is 1, this is a sub 2 plus 2a sub 1. You don't even have to do that if you understand what it's really telling us. It's telling us a term is the same as the previous one plus 2 times the one even before that. So now plug in. A sub 2 is 2 plus 2 times 1. All right, so with this being the case, what is a sub 4? Take a look. A sub 3 is a sub 2 plus 2 a sub 1. So a sub 4 is a sub 3 plus 2 a sub 2. So a sub 3, we just found it, plus 2 times a sub 2, 2 times 2, and they add up to 8. Again, you're showing your reader a couple of them with details. That means you can show the rest of them as well. And this is it. Okay, everybody? This is it.
When you say with details, do you just mean like showing your work?
This is it. You are showing your work to your reader. A
Okay.
sub 3 equals a sub 2 plus 2a sub 1. And the reason you want to do that, even if you go back to your own notes, and you didn't have this, you just wrote that, you may be confused. How did I get that? Okay. So that's why go with the formula, add them up step by step for a couple of them. So it makes it easier when you go back to it next time, even 2 months down the road, this makes a perfect sense to you. Okay. All right. So what happens with the limits? I hope you remember, basically we plug in. We plug in when we observe. In this cases, when we plug in, let's see what happens. This is 2 to the power of infinity, which is infinity. And by the way, if anybody says, okay, is it convergent or divergent? Infinity means divergent. Plug in. We've done this stuff. Plug in. And I hope you remember 2 to the power of negative infinity goes to 0. Therefore, it's 5. The reason it goes to 0, because recall, a to the power of negative m is 1 over a to the power of m. So 2 to the power of negative infinity is 1 over 2 to the power of infinity, which is 1 over infinity, which is 0. The next one, plug in, and of course, this is 0 again, and there you have it. All right. How about here? When you are dealing with a rational expression and you're taking a limit as n goes to infinity, it actually becomes infinity over infinity. I want you to know that. And let me actually go over this concept of indeterminate again. When you work things out and it gives you 0 over 0, infinity over infinity, infinity minus infinity, things of that nature, it means indeterminate. That means we need to use our algebraic technique to fix the problem. And I hope you remember, the algebraic technique for a rational expression is to divide by highest degree term in the denominator. In this case is n squared. I hope everybody remembers that. Okay. And so what happens next? As you can see, everything goes to 0 with the exception of 2 and 5. So the answer becomes 2 over 5. And we are done. Okay, everyone? All right. We've seen this question. I'm not going to spend too much time on that. I want to look at a question which is similar to that, but sometimes I've seen students having difficulty with that. So to recap this, I hope you remember this is a repeating decimal. And again, there are different ways of getting to the rational expression for that rational number, but this is one way using the geometric sequence, noticing the first term is 46 over 100 or 0.46. Then we are dividing by 100 or multiplying by 1 over 100. Therefore, we can use the geometric sequence. Remember, the sum for this one, okay, we get to this answer if r is between -1 and 1, makes it easier. A over 1 minus r. A is the first term. So here's the first term, here's the r, here's s sub n, and that's exactly what's going to happen here. So the first term is 46 over 100, 1 minus r is 1 over 100. This is a complex fraction. You multiply by 100 over 100. This gives you 46. The bottom gives you 100 minus 1, which is 99. And there you have it. However, I wanted to look at this question, which is slightly different. What is the difference? The difference is that the bar is not at top of both, but rather only one digit, and therefore is 3.1666. It is number 6 that is being repeated, everybody. And so you can cut them into two pieces, the 3.1 and then this part which is being repeated. Let me write at top of it what I mean by that. You can write it as 3.1 plus 0.0, and now the 6 repeats, okay? And this is the repeating part. Let's see what happens. I want to make sure we understand. The first term, okay, is 0.06 or 6 over 100. The next one is just divided by 10 or multiplied by 1 over 10. I hope you see that. That's why it is slightly different than this one. So for this part, the first term is 6 over 100. And again, we can simplify it, but let's keep it as that. You see in a moment why. R is 1 over 10, and S sub n is A over 1 minus R. We are going to calculate this by following exactly what happened here. This one, this one, this one. And this piece, we can multiply the top and the bottom by 100 again. So the top becomes 6, and the bottom becomes 100 minus 10, which is 90. We are looking at a complex fraction, everybody. So let's quickly recap. 3.16 bar is 3.1 and then 0.06 bar. By the way, this one you can say 0.06 bar, meaning this. Let me just show you. This part is 0.06. The bar is at top of 6 only. That's another way of writing it, okay? All right, so using the same methodology, we write it in this fashion. Now this becomes 90. 6 over 90 we will simplify. Now take a look at what I'm going to do. In order to see how we add them up, 3.1, I'm going to write 3 plus 1 over 10. 6 over 90, I can write it as 1 over 15, but I'd rather do 2 over 30 because I need to take a common denominator between these two pieces, which is 30. Okay, so this becomes 3 and 2 becomes 5 over 30, which is 1 over 6. And again, as I mentioned, maybe in WebAssign, they want you to multiply and write 3 times 6 plus 1, 19 over 6. But anyways. So the only reason I picked this one because it's a little bit different than this, okay? But it's not by much. It's really doable, okay? All right. As you recall, we have a recursion in the geometric sequence where we are dealing with patients. That means what matters is that you're constantly adding, some constant amount for the patient. So a doctor prescribes 100 milligram of antibiotic, okay, every 8 hours. 8 hours is extremely important, doesn't enter the formula. Just before each tablet is taken, 30% of the drug, okay, remains in the body. Remember, what matters is what remains in the body. So first of all, for B sub n plus 1, we're going to change this to Q sub n plus 1 for part B. And because of that, I want to write the given here with Q. So B sub 0 or A is going to be Q sub 0 or A, which is 0. It's always 0 unless somehow they mention it here. What is the constant? 100 milligrams. What is the R? What is remaining in the body? 30%. So let's write the given. When you write the given, makes every other part a piece of cake. And by the way, for the exam, for now, you can use this formula. Okay, if you want to put the formula in front of you and use it, that's fine. But only this formula, nothing else. Okay, class. So let's go and find how much drug is left after the third tablet by setting this up. Of course, the first one is 100. We know that, right? Because that's a constant. What is the second one? Well, if 30% remains, 30% of this is 30 plus 100 is 130. And then 30% of 130, okay, which is 39 plus 100 is 139. So this is 130, this is 139. I hope you realize it's very straightforward. There is not much to it, everybody. So as far as this formula is concerned, so that's that. Again, we are repeating questions we have seen. This is slightly different, I think, okay, than what we have seen, but we've done questions similar to that. And then next one, we want to write Q sub n plus 1. The very first thing we do, B sub n plus 1, let's change it to Q sub n plus 1. Let's do that first. And now what is R? Replace it with 0.3. What is lowercase c? Replace it with 100. So I hope you see how easy it is. Compare and write the answer. Okay, we want to solve the formula for Q sub n. Compare, and first and foremost, B sub n, everybody, change it to Q sub n and write this formula. So we are changing everything to Q sub n. So this formula, Q sub n. So it's just being repeated with Q. Now, let's go put in. Q sub 0 is 0. C, 100. R, 0.3. So put in the given. So even if it takes you a couple of minutes to read and write the given, so be it, because it's worth it. And now we know how to handle this. We've done this before. So here's the methodology. You change this to 0.7. And this one, you're going to say 100 divided by 0.7, which makes it 1,000 over 7. And by the way, this is 0. So 1,000 over 7 times 1 minus 0.3 to the power of n. The reason you do that, because it will help you with the next part, which is basically taking the limit. Okay. Now let's take a limit. By the way, the next part, use part C to find Q sub 3 class. If you use n equals 1, gives you 100. If you use n equals 2, gives you 130. If you use n equals 3, gives you 139. You can check it. Okay, you can check. Let's take a limit. As you do, I hope you realize and you remember, because this is between -1 and 1, this goes to 0, everybody. This goes to 0. So 1,000 over 7 times 1 minus 0. And this is a precise answer, and this is an approximation, okay? So now what happens? This is the most important thing you want to remember. What it means, every 8 hours, it will never go beyond that if we keep on giving the antibiotic. So it's important to the patient, to the nurse, to nurses, doctors, everybody involved. No matter what you do, it won't go beyond that, and it has been calculated accordingly to make it safe for the patient. So that's an important piece of information. All right, let's do more limits. When you have a rational expression and t or x or any variable n approaches infinity, the technique is to divide by the highest degree term in the denominator and rewrite it. We've done all of these questions on this page. So I'm going to go pretty fast, just reminding you. Everything goes to 0 with the exception of 1. And why is this important? Because 0 over 1 is 0. 0 over 1 is 0. What happens here? You divide by highest degree term in the denominator, which is t. You simplify. So t is approaching infinity. So this piece and this piece, they go to 0. This is infinity plus 2 over 5. So ultimately, you get infinity. Okay? What happens here? If we plug in, we get infinity minus infinity. When we get to infinity minus infinity, which is indeterminate, the technique was to multiply by the conjugate and divide by it. So when we do that, this piece comes out, becomes x squared plus 1, minus x squared, and you don't touch the denominator, you keep it. These two cancel each other. And you get 1 in the numerator only. And now I hope you realize if you plug in, the denominator gives you infinity plus infinity. And 1 over infinity plus infinity, it is again 1 over infinity, which is 0. All of this we looked at before. I'm refreshing your memory, everybody. I hope everybody's okay with that. We are going to look at more examples, class. So again, questions we have seen before, nothing brand new. And the very first step, plug in. I hope you realize when you plug in, you get 12 divided by 4 plus 3 times e to the power of negative infinity, and that is 0. And so 12 over 4 or 3. So again, I want to make sure everybody understands what happens here. Class e to the power of negative infinity means 1 over e to the power of infinity, which is 0. That's how we get this, okay? Part B is not a rational expression. We treat it as such because this is approaching infinity, okay? And again, remember, even this one, you can plug in. I hope you realize if you plug in, you get infinity over minus infinity. I want you to know that. So we divide by the largest piece, e to the power of t, the top and the bottom, and it simplifies as follows. I hope you remember that. This goes to 0. This goes to 0. You end up with positive 1 over negative 3, which is negative 1/3. Negative 1/3. What happens here if you plug in? You get infinity minus infinity. In determinate form, it requires a technique. The technique involved is to factor the x out. Now, practically, you're done because when you factor the x out, you get infinity times infinity minus 1, which is still infinity class. Okay. Okay. Reminding you of how to read the limits from the graph. First, we want to find the limit basically as x approaches 2. Therefore, we look at one-sided limit. So this is number 2. We look at the left side. That means this branch, it brings us to this hole having a y coordinate 3. From the right of 2 in this branch brings us to the different hole with the y coordinate 1. Because they are not identical, the limit doesn't exist. I hope everybody remembers that. So what is the limit of g of x as x approaches 2? Does not exist. Why is that? They must be identical and they are not. All right, how about number 5? Okay, here's number 5. From the left, we are in this branch and we're moving towards this hole. From the right, we are in this branch and we are moving towards the same hole, everybody. And both of them result in the same y coordinate 2. I hope you see that, this point. This is the limit, the y equals 2. Therefore, because the one-sided limits are identical, the limit does exist, and we are done. One of the things I want you to notice, class, the functional value for 2, that means g of 2, we don't know, it's not given. But the functional value for 5, it's this one, I don't know, it seems to be 1 point something, okay? So g of 5 is not equal to the limit. In both cases, the function becomes discontinuous. But this one is called a jump, and we can't fix it. This one is called a removable discontinuity. We can fix it, but you don't have to worry about that. But the point being, the limit does exist. Okay. How about the graph? We are going to look at the limit of the function as x approaches various numbers. Let's go with 2. Take a look at the graph. In both sides of 2, this goes down to what?
Negative infinity.
Beautiful. What about number 5? Both sides of number 5?
Positive infinity.
Perfect. Okay, we are looking at number -3. From the left side of -3, that means -3 from the left. That's how this one is read. -3 from the left.
Negative infinity.
Beautiful. And now -3 from the right.
Positive infinity.
And therefore, we have the equation of VA, or vertical asymptotes. In this case, x equals 2. In this case, x equals 5. In this case, or in this case, both of them result in x equals -3. There are 3 vertical asymptotes. Very straightforward, class. Perfect. Perfect. All right. Let's look at more examples of limits, starting with this one. And I hope you realize when we plug in, remember, we can just plug in and observe. When we plug in, we get, what do we get?
Zero.
No. What do we get, class? 0
Over 0.
over 0, which is different than 0, which is different than undefined. 0 over 0, because if you get to 0, you're done, class. That's the perfect answer, you're done. If you get to 0. So it's important to realize you do not get to 0, you get to 0 over 0, which is indeterminate. And therefore, what was the technique to fix the problem? We would multiply and divide by
Conjugate.
Beautiful. We're going to multiply and divide by conjugate, which simply put this negative, we change it to positive. We put it at top, we put it at the bottom. Okay, so this guy comes out as x plus 3, and this guy comes out as minus 2 squared, which is 4, and the denominator you just write. So the first piece comes out minus the second piece squared, which is 4. If you put the top together, you do end up with x minus 1, and we are going to cross it out, and so the numerator is left with number 1 and nothing else. Okay, class? And so plug in, there you have it, because 1 gives you 4, square root of 4 is 2, and 2, 4, and you're done. In both cases here, class, I want you to see that when we plug in, the top is 6 and the bottom is 0. We've discussed that before, so let's just pay attention to that. When I say the top is 6, see, the number 6 or 5.9 or 6.1 makes no difference. The top here is really like 6.00001, and this one is 5.999. The only number that you want to be concerned with when it's 0, because this depends on the right side or left side, 0 becomes what? Positive or negative. Why is this important? We know when we divide by 0, we end up with infinity. We just don't know infinity or negative infinity. We need to know 0 from the left or right. And so in this case, 6 from the right, such as 6.1 minus 6, gives you positive 0.1. So 0 from the right, positive over positive, gives you infinity. On the other hand, for this one is like 6 from the left, like 5.9, and that gives you minus, and therefore positive over negative is negative infinity. Okay, that's extremely important, everybody, to understand how this works. For number 28, I hope you realize when you plug in, you get 0, but you do get 0 from the right. And remember the graph. Of y equals ln x. From the graph, you can see the answer is negative infinity, everybody. The answer is negative infinity. All right. What did we do here? Again, if you plug in, you get 0 over 0. But in the case of a rational expression, when x is not, this is not approaching infinity, okay, class? The technique is factoring. It's important to see that we don't want to mix them up. So drop the x plus 5 from the top and the bottom, and you get this one. So the top becomes minus 5, the bottom becomes minus 10, which is positive 1/2. So I can write that for you. It's the top becomes minus 5, the bottom becomes minus 5 minus 5, which is negative 5 over negative 10, giving us positive 1/2. All right, for the next one, I hope you remember we did this, the technique. Remember, plug in, you get 0 over 0, class, 0 over 0, okay? If you don't get 0 over 0, you can finish up the work. But 0 over 0 technique is LCD. So when you multiply this by 1/3, you get x minus, and you multiply it by 1 over x, you get 3. You drop the common factor of x minus 3. You get 1 over 3x. The limit as x approaches 3 of 1 over 3x when you plug in is 1 over 9. 1 over 9. So what happens? What happens here, class? What happens when we plug in? Anybody?
Wouldn't it be 4 if you just plug in?
And that's it. What is the point? The point is plug in and observe. It may work. You're done. Okay? We just plug in. It works out. We're done. And that's the thing. You don't have to do anything in this example. All right. Let's start with the easiest question up here. Can anybody tell me what happens if you plug in? And by the way, you can factor the top into x times x minus 6 if you want. That's fine. There's nothing else we can do. Let me even write that. So you can factor this to x times x minus 6. By the way, these questions come from, some of these questions come from what? Your exam review. My assumption is you've done most of your exam review class. So can anybody tell me, what happens here if you plug in?
It goes to infinity.
No. Okay, well, what is the numerator? Just the numerator, never mind the denominator. What does it give you? Numerator.
0,
0. What is the denominator?
3.
Thank you. The answer is 0. So I hope you see that if you plug in everybody, you get 0 over some number. It doesn't matter the denominator is 3 or any other number, as long as it's not 0, 0 over any number is 0. And that's my point. Plug in, it might work. All right. What about 36? What is the technique? First of all, if you plug in, what do you get?
0 over 0.
Beautiful. Technique?
Conjugate.
Beautiful, beautiful, beautiful. So the first one comes out as 49 plus h minus 7 squared, which is also 49. We don't touch the denominator. We keep it as a product. 49 cancels out negative 49, everybody. Let's do that. And the numerator is left with h. You can drop this h, and the numerator changes to 1. And now if I plug in 0, I get 49 square root of 49 is 7. 7 and 7 is 14. 1 out of 14 is the final answer. All right, as for number 37, again, x is approaching some number, it's not infinity. If you plug in, you end up with 0 over 0 class, okay? If you plug in, you get 0 over 0. And the technique is factoring. And here's what I'm going to add, and I'm going to remind you. Remember, x is approaching negative 4, so most likely we have a factor of x plus 4. So that should help you with factoring. I'm assuming everybody is comfortable with the factoring. This was question 37 of exam review, okay? Now, practically you're done. Plug in negative 4. 3 times negative 4, negative 12, and negative 1 is negative 13. 3 times negative 4, 2 times negative 4 is negative 8, and 3 is negative 5. And that's the final answer. I want to look at the last section, everybody. I want to look at the last section. Again, we went over this and the concept of a secant line versus a tangent line, okay? And as I mentioned, the equation of a tangent line, just stick with the point slope. So I want to find the equation of a tangent line. I need two things. I need a pair. It's given to me. I also need the slope. So how do we find the slope? We use one of those definitions. For example, if we use the top definition with a being 1, we've done this question, by the way, class, okay? So we are interested in m, which is f prime of 1. The limit of f of x minus f of 1 over x minus 1 as x approaches 1. What is f of x? X squared. This is simple factoring. Everybody knows how to do that. The top becomes x plus 1 times x minus 1. The x minus 1 drops. Plug in 1, gives us 2. And practically we're done. We are done with the calculus. We do algebra, which is y minus y1 is m times x minus x of 1. We have the slope. We have the pair. Plug in. Before I go to the last question. Let's just quickly look at this second method because you really have a choice class. Any of them you can do. Again, for practice, we want to look at that. And we are looking at a being 1. So what do? We plug in 1 plus h into the function. And what do? We square that. One plus 2h plus h squared, 1 and negative 1 cancel out. The top, we can factor out the h. The h cancels out. And if you plug in, you get 2. And look at that. That's the same as this number. And that is the point. We are not going to get any other number. I'll just show you the second method. Do you have to do the second method? Absolutely not. One method is enough, class. But I want you, of course, to be exposed to both of them. Last question. We want to find the velocity of the object from 2. The moment you have 2, this is the function. Again, we've done this in section 3.1. I'm just refreshing your memory. The distance of an object given as s of t equals 2t squared minus 5t plus 4d. What is the velocity of object from 2? That means average velocity. Find the total distance over total time. Okay, so plug in 4. Plug in 2, we get 52 and 38, subtract them, divide by time, and you get 7 feet per second. But for the second part, notice it's at 1 point. Now that means instantaneous velocity. Everybody, instantaneous velocity requires the limit. And again, it becomes easier later on in other sections. We look at methodology that is easier. But anyways, for now, we use the definition of differentiation, where a is 4 here. So let's put it into this. So 2 times 4 plus h squared minus 5 times 4 plus h plus 4d. Now, s of 4, you can actually, as I mentioned, you can even use 52 here. Now, again, I've gone over this with details last time. I'm not going to do that. It is purely algebraic technique to finish the numerator and write the simplified version. And h and h cancel each other. You're left with 2h plus 1. So the limit of 2h plus 1 as h approaches 0 is simply 11, which makes it 11 feet per second. And that's it.